Welcome back to the lecture series of atomic spectra. So far, we have discussed atomic model, types of a spectrum, spectral lines, and in this lecture, now we are going to discuss the quantization of radius. We are going to derive the expression for quantized radius. When Rutherford performed the experiment using alpha particles as the probe to see what is inside the nucleus, तो experimental observation के basis पे he came up with the picture of atom. He said that nucleus is the tiny part of the atom. It is positively charged, it is dense, carries 99.99% of the mass of atom, and it is situated at the center of atom. Then he said, क्योंकि most of the alpha particles passed undeflected through the gold foil, right? So he said कि atom is largely empty. And then he said that electrons are present around the nucleus. लेकिन क्योंकि तब तक जे थॉमसन के एक्सपेरिमेंट से ये कंफर्म हो चुका था कि इलेक्ट्रॉन कैरीज नेगेटिव चार्ज एंड इट वाज ऑब्वियस थ्रू दिस एक्सपेरिमेंट ऑफ रदरफोर्ड कि न्यूक्लियस कैरीज पॉजिटिव चार्ज, तो फिर पॉजिटिव और नेगेटिव चार्ज के दरमियान देयर हैज टू हैव सम इलेक्ट्रिक फील्ड, राइट? एंड न्यूक्लियस की इलेक्ट्रिक फोर्स की प्रेजेंस में ये कंसिडर करना कि एटम के अंदर मौजूद जो इलेक्ट्रॉन है वो स्टेशनरी है, it was not making sense. So it was decided, it was concluded that electron is revolving around the nucleus in almost circular orbits, right? इसका मतलब है, फिर we can say that in this case, Coulomb's force is playing the role of centripetal force. So F centripetal is F coulombs, right? How do we write centripetal force? It is mv square over r, where this m is the mass of the object performing circular motion, v is the velocity of object, and this r is the distance of this object from center of circle. How do we write Coulomb's force? We have this k as constant, and then we have product of both the charges जिनके दरमियान force of attraction या repulsion हम calculate करें, divided by square of the separation between these two charges. यहाँ पर हम किन दो बॉडीज के दरमियान कूलम फोर्स की बात करें? पॉजिटिवली चार्ज्ड न्यूक्लियस एंड नेगेटिवली चार्ज्ड इलेक्ट्रॉन के दरमियान अट्रैक्शन फोर्स की हम बात करें। न्यूक्लियस पर चार्ज क्या है? अगर हम स्पेसिफिकली हाइड्रोजन के न्यूक्लियस की बात करें तो हाइड्रोजन के न्यूक्लियस में सिर्फ एक प्रोटॉन है, राइट? सो प्रोटॉन का चार्ज क्या होता है? वही जो इलेक्ट्रॉन पर चार्ज होता है, बिकॉज यहाँ पर हमें सिर्फ मैग्नीट्यूड प्लेस करना है, सो विल राइट ई हियर। देन सेकेंड ऑब्जेक्ट क्या है जिनके दरमियान ये फोर्स एक्ट करिए? इट इज इलेक्ट्रॉन। इलेक्ट्रॉन का चार्ज क्या है? इट इज ई। सिंस वी आर टू राइट द मैग्नीट्यूड हियर, तो फिर हमने उस नेगेटिव को इग्नोर किया, बिकॉज इन दोनों का charge का magnitude is exactly equal. The only difference is in the nature of charge, right? How about the separation between these two charges? The separation of the electron revolving in a particular orbit from the nucleus is termed as the orbital radius, जिसको we represent with r. If we are considering that this electron is revolving in first orbit, तो फिर we call this orbital radius, we represent this orbital radius with r1. And if we are considering an electron revolving in second orbit, तो फिर we label this radius as r2. और हम यहाँ पे क्योंकि एक general expression derive कर रहे हैं ना, so we are going to label this radius as rn, किसी nth orbit का radius, and same goes here. Then what we are going to do here is we are going to put the value of velocity here. अब वो velocity की value कहाँ से आएगी? From Bohr's postulate. He said that जो stationary orbit है उनकी condition क्या है? Angular momentum, that is mvr, equals integer multiple of h cut, जिसको we can write h over 2 pi. Let's just rearrange this equation to get the expression for velocity. It becomes v equals nh over 2 pi with this mr here in the denominator. Let's just put the value of this velocity into this equation. Let's just label it as equation number 2, and this was our equation number 1. Equation number 1 becomes m as it is, velocity square, it has to be nh over 2 pi mr square, then this rn in the denominator, and then on right side of the equation we have k e square over rn squared. Let's just move this square, it becomes m n square h square over Rn. 2 square is 4, pi square, and then we have m square Rn square equals ke square over Rn square. Let's just simplify this equation. We have this Rn square here, and then we have this Rn square here. This gets cancelled, and then we have m square here and an m here. So let's just cancel these two. Rearranging this equation in terms of orbital radius for nth orbit. So we have Rn in the denominator, right? So let's just move it to this side. This becomes Rn, and then here we already have n square, h square. Then in the denominator, we have 4 pi square. This Rn has already been moved to the other side of the equation. And we have this mass in the denominator, and this ke square from right hand side has to be shifted here, right? This becomes ke square. This is the expression for orbital radius, right? We know that this h is constant, 6.63 exponent minus 34. 4 is constant, pi is constant, m, which is the mass of electron, is constant, 9.1 exponent minus 31. This k is also constant, वही Coulomb's law वाला, जिसकी value is 1 over 4 pi epsilon naught. And this E, which is the charge of electron, is also constant. Remember, 1.6 exponent minus 19. इसका मतलब all these values are constant. So we can also rewrite this equation as Rn equals n square times this constant. And this constant is what we can calculate just by putting these values and simplifying this equation. And when we do so, this turns out to be 0.053 nanometers. So it is 10 raised to the power minus 9, right? So we can, let's just write it as nanometer as well. ठीक? This is the radius for nth orbit. We locate different orbits with their principal quantum number, that is this n. For first orbit, this n equals 1. For second orbit, this n equals 2. For third orbit, this n equals 3. That is, if we are to calculate the radius of first orbit, r1, it should be 1 square times 0.053 nanometers. If we are to calculate the radius of second orbit, we must write 2 square 0.053 nanometer, and for R3 we can write 3 square 0.053 nanometer. 1 square being multiplied with any number does not make any difference to it, right? So we can write it as 0.053 nanometer, and by the way you will see कहीं पर लिखा हुआ इसको 0.53 एंगस्ट्रॉम, बिकॉज पॉइंट को अगर एक डिजिट राइट पर मूव करवा दिया गया तो पावर नेगेटिव में इंक्रीज हो गई होगी. Now 10 की power minus 9 would have become 10 की power minus 10, and this 10 की power minus 10 is nothing but angstrom. इसको angstrom से भी show करते हैं. So this is what we call Bohr's radius for first orbit of hydrogen atom, right? और मुझे पता है ये सारी वैल्यू 0.053 यहाँ भी है, यहाँ भी है, तो इन सारे किसी भी हाई लेवल के रेडियस को मैं बोर्स फर्स्ट रेडियस के टर्म्स में भी लिख सकती हूँ. अब मैं जब मुझे पता है दिस वैल्यू इज r1, so we can write it as 2 का स्क्वायर, right? So we can generalize it as n square multiplied by r1, right? So all in all, I should be writing 4 times r1 is the radius for second orbit. Likewise, 9 times r1 is the radius for third orbit, and 16 times r1 is the radius for fourth orbit, and so on. Hence, we could write this equation for radius of nth orbit as square of the principal quantum number times first Bose radius in hydrogen atom. Now, why do we even call it quantization of radius? Because this final expression suggests कि radius की कोई भी value नहीं हो सकती. Electron nucleus से किसी भी random या किसी भी continuous distance पर orbit नहीं कर सकता, right? या तो it would be 1 times Bose radius, it would be 4 times Bose radius, 2 times and 3 times are not allowed, right? It would be 9 times Bose radius, 5, 6, 7, 8 times the radius is not allowed, right? So we have concluded कि radius की भी कुछ discrete values allowed है, right? So this is why we call it quantization. This is the final conclusion from this lecture. In the next video, we are going to derive an expression for wave number in terms of energy levels, and then we'll use this expression to solve the world problems. Till then, Allah Hafiz.